All right, lessons 3 and 4 in Unit 8 are dealing with the law of sines and the law of cosines. And so I love this lesson. It's very heavy on algebra skill. And so as long as you love algebra, this should be a fun thing. If you've struggled with geometry and you're not really a big fan of it, that's okay today because we're going to be doing a little algebraic investigation into the relationship between the sines of and cosines of angles in triangles and the lengths of the other sides in the triangle. So we're going to focus on some angles, we're going to focus on some sides. We need to know a little bit of our SOHCAHTOA, because that just helps us do our exploration today. So make sure that you've committed these to memory, have those in your notes, it's always useful. And so we're going to explore the sine ratio first, and then we'll do some exploration with cosine first. So this is going to focus on the law of sines. It's kind of like part one. And the goal here is to recognize that we have this triangle ABC, and we've drawn an altitude from this vertex over to side BC, all right, which has the length of A. All right, now this original triangle ABC does not have to be a right triangle. Thus far, we've been working with right triangles specifically, and we're still gonna be using right triangles because we draw this altitude, and this we're just gonna call, like, that measurement is the height of the triangle, like you usually would. And we're gonna explore what is the sine of angle B, and what is the sine of angle C. So the sine of angle B is going to be this altitude over the new hypotenuse in this triangle. So the sine of this angle, even in the original triangle, which isn't a right triangle, is found by taking this perpendicular distance divided by the length of this, what is an adjacent side, right? It's not like in cosine where it's like this adjacent leg. This is the hypotenuse in this new triangle. So the sine of angle B is h over c. And likewise, the sine of angle C is going to be h over little b, all right? The length of this side that's opposite side B, the length of this side that's opposite side C. All right, so that's where those little c's and little b's come from. Now, the question is, if I make these, if I do my cross product, I have C times the sine of the angle, capital B, and B times the sine of the measure of the angle at C. They're both going to equal the same thing. They both equal whatever that height is in our triangle. Now this is going to be very useful to us in a later section of notes because we're going to find the area of the triangle, trying to do base times height, and we're going to have to find out what the height of the triangle is. We're going to be able to use angle measures to help us do that. All right, so anyway, moving on. We now know if these things are equal to the same thing, then that means that those things are equal to each other, right? That's the transitive property of congruence. You could also, transitive property of equality, or you could use substitution. But if this equals that, and that equals this, then these two things are equal to each other. And if that's the case, then I can divide both sides by C. It would cancel out on this side. And then I divide both sides by B. It would cancel out on that side, and we're left with this fraction. Okay, so understanding how the algebra works and doing some fancy thinking, we arrive at this result. That the sine of this angle divided by the length of its opposite side is equal to the sine of this angle divided by the length of its opposite side. And we can extend that even further. So in any triangle ABC, whose sides are length A, opposite side A, length B, opposite angle B, and length C, opposite the angle at C, is going to be, we can find those relationships taking the sine of angle A over the length of the side opposite angle A, the sine of angle B over the length of the side opposite angle B, and that is all equal to the sine of angle C divided by the length of the side opposite angle C. So this is the law of sines. Now typically we're not going to write three different ratios. We're not going to use this extended proportion. Instead, we're going to write these two at a time. And we will have some pieces of information, at least 3 of these letters. We will have numbers, either angle measures and a side, or 2 sides and an angle measure, and then we will be able to find the missing piece. All right, and so here's 2 different situations. Draw these pictures to the best of your ability, label them appropriately, X, Y, and Z. And what we have here is this situation where we have these 2 angles, we have this side, and we don't know what this is. And so we're going to try to find the length of this segment, YZ. The distance between these points is the length of this segment, which I'm going to call X. And our equation, if we know our formula, the sine of A over A is equal to the sine of B over B, then we can create this equation that says the sine of this angle over its opposite side length is equal to the sine of this angle's measure divided by its opposite side length. Now, I know that initially we want to jump to our calculators and start typing things in, but folks, what we have learned is that we will do a much better job if we do all of our algebra and then go back and grab our calculators. That's going to be our anthem today, is let's do algebra, and then let's let the calculator take care of the calculator later. All right, so when we do 7 times the sine of 51 and x times the sine of 77, we do that cross product. X is not by itself yet. We have to do this other step of divide both sides by the sine of 77. So we have 7 times the sine of 51 divided by the sine of 77. And that is what x is going to equal. And we can approximate what that's going to be here in just a little bit. But again, I want us to do algebra and then worry about the calculator later. All right? So we've got that. That's what x equals. And we'll approximate x here in just a moment. Over here, we're going to find the measure of this angle. That can be x if we want it to be, all right? And so we know our formula, the sine of in this case, angle S over the length of side S is equal to the sine of the angle at T divided by the length of the side opposite T. All right, and so this is going to be my variable. I'm going to have the sine of x over the length of the side opposite is equal to the sine of this angle divided by the length of the side opposite. And so these have units. These units aren't going to matter because our answer is going to be in degrees. Over here, we didn't have units. If I knew that these were feet, then I'd answer with feet. But we're just going to kind of approach it in this regard. And so now when we do our cross product property, we get 12.3 times the sine of x is equal to 12.7 times the sine of 74. Well, again, x isn't by itself. We're going to divide by the 12.3. All right. So, so those of us that are like to do fishies and butterflies and all that weird middle school math there, you're allowed to do that here. That would have saved you a step. But the goal is we want to take this 12.7 times the sine of 74 divided by 12.3, and then we want to take the inverse sine of that whole gigantic fraction. All right. Using our inverse properties. So this is what x equals, but we want to find out what does x approximately equal. What is going to be the measure of angle S is going to be approximately equal to what? So for both of these, we're going to use our calculators and we're going to use them carefully. We want to use our calculators carefully to make sure that we actually close parentheses, all right? That we actually close parentheses and pay close attention to how we operate with our calculator. So when I type 7 times the sine of 51, and I divide that by the sine of 77, it gives me this output, 5.58. And so we're going to round that to 5.6. 5.6. So x is approximately 5.6, whatever those units are. And does it make sense that this would be 5.6, whatever the units are? Well, this is 77 degrees, so this side should be longer. This one is 51 degrees. This one should be shorter than the one that's 77 degrees. And it's hard for us to approximate what that would be or guesstimate, but it should be clear that this is an acceptable possible answer. All right. Hopefully we didn't make any mistakes with our calculators. For the other one, again, we did all of that work, and now we're going to try to type things correctly. We've got the inverse sine of 12.7, times the sine of 74, close parentheses, divided by 12.3, and then close the whole parentheses for the inverse sine. All right, this gives us 82.98 degrees. We're going to call that 83.0 degrees. So we get 83.0, all right? 83.0. If you don't put the degree sign in there, that's okay. We are putting the 0.0 there because that shows us that we rounded to one decimal place, all right? So the 0.0 is valuable. The degree sign is not required, all right? I know it sounds a little bit silly to require units when there's feet or meters or miles, but not require units when there's degrees. And that is because at this point, you do not know of any other measures or any other units of measures for angles, all right? But when you go into pre-calculus, you'll learn some more. All right, now let's explore cosines. This is kind of the part 2, all right? And that's why this video is maybe a little bit longer than whatever, but we're 10 minutes in-ish. And here we go. So again, same situation, triangle ABC. We're drawing this altitude again, and we have this whole length A, but we're going to call this x and this A minus x. Just bear with me on that. This is the whole thing. If this is x, then when I subtract this part off, I'm left with a minus x. All right, so bear with me on that so that we have these expressions. Now, what you're going to see me do here is looking at this right triangle here. We know that c squared is equal to this squared plus that squared, if I'm just looking at this triangle right here. So c squared equals a minus x squared plus h squared. Now, the multiplying of a minus x times a minus x foils out, right? First outer, inner, last, we do double distribution, we get this expression plus h squared. I know that's confusing. That's algebra 1 though, and so hopefully we know how to take a minus x times a minus x and do double distribution. When we work with this magic, we are going to see that we have this strange thing of x squared and h squared. Well, x squared plus h squared is equal to b squared. And so I've substituted those, or I replaced those with b squared. This part is that. All right, when I do double distribution, I get a squared minus 2ax plus x squared. But then I've seen that this x squared plus h squared is b squared. All right, so now I have this expression representing the length of side c squared. But now I'm going to do a little bit of other math magic here. We're going to recognize that we have this magical relationship with what x actually is. X we can find using cosine, right? X we can find using cosine, saying that the cosine of this angle is equal to adjacent over hypotenuse, all right? And so if I multiply this by both sides in there, then I find out that b times the cosine of c is x. b times the cosine of c is x. And so what this lets me do is it lets me kind of shift some things around. And I have this weird addition, I know subtraction, but this weird addition to our Pythagorean theorem piece. Now, our original triangle ABC is not a right triangle, but by breaking it into right triangles and knowing hopefully the measure of an angle and two sides, we can find the length of the third side. Or if we know three sides, we can find the measure of the angle, all right, using cosine. All right, so we can kind of do this forwards and backwards. This one is a little bit trickier, but this works for any side in the triangle, any sets of sides. And so the law of cosines is always going to relate the cosine of each angle to the side lengths of the triangle. So if you have A, B, and C, you're going to use B and C with the cosine of the angle. If you're using B and you have A and C, you're going to use A and C with the cosine of B. However, I want us to focus on just using one standard formula. And so this is going to be our formula that we are going to use. That's what we use to derive the relationship. And really what's happening here is that we are focused on a situation where angle C is not a right angle. This does work if you do the cosine of 90, all right? That will actually zero this out, so you won't be subtracting anything from a squared and b squared. But if C is a different measure, then that changes things. So notice this, these are the same numbers, right? Here and here. This is A and this is B. This is the side opposite the angle that we know. So either we are finding this angle or we are finding this side. Or we have this side or we have that angle. So if we have the angle, then we're looking for the side. If we're looking for the angle, then we have to have this side and the others as well. All right? So let's kind of talk about how this is going to be a law of cosine situation. So first of all, if I am trying to use the law of the law of sines. If I go back and I'm trying to use law of sines here, this isn't going to work, all right? Because I have this pairing right here. I have this pairing right here, but I don't know either of these angles. So I cannot use law of sines here, right? There's not enough happening. If this is BC, this is going to be my variable. That's what I'm looking for. We cannot use the law of sines. So if you write your formula for the law of sines, you're going to notice that, well, I have this pair, but I can't, and this is a variable, but I can't figure out that and I can't figure out that because I don't know what this is. If I knew this measure, then I could find the measure for the angle C or the measure for the angle B. But here, the way that these are set up, it will not allow us to use the law of sines. And so that's how you know you have to use the law of cosines here. So again, C squared is equal to A squared and B squared, just like the Pythagorean theorem was, but minus 2AB times the cosine of angle C. Well, here's what's weird about this. Angle C is not what we're looking for. We're looking for angle A. So that probably confuses us a little bit, right? But we've got to be flexible with a formula to know what goes where, all right? So if this is the angle and the side that we're looking for, then this is x, and this is the measure of the angle that we're going to be taking the cosine of. You need to be able to identify that, all right? The other two sides, you can call them A and B. It doesn't matter which one is which. I know that our triangle is labeled differently. The whole point of a formula is who cares what the letters are, who cares what the numbers are, where can these things fit into our construct? And so we're going to have 8 squared and 10 squared minus 2 times 8 times 10. And then times the cosine of the angle that we are investigating. So what's great about this situation, if we're finding the side, the formula is already done. And what I love about that formula being already solved is you can just type this in your calculator and it'll spit out the answer. I want us to get away from using the calculator for every single step along the way though. Whoops, squared. And I want to make sure that we can do some of this thinking before we get too carried away into our work. And what I mean by that, folks, is just making sure that we understand a little bit about the order of operations. The number one thing that students mix up when they're doing this, and it's not usually on this one because you can just type this whole thing in and it'll give you the answer, but it's on this one. And so I want to be clear about two things. These are not like terms. These cannot combine. And the reason is this is 164, but this is 160 times the cosine of 57. So this isn't 160. This is 160 times the cosine of 57. And we know the order of operations. We have to multiply before we subtract. All right, so I cannot combine those. These are not like terms. I don't get 4 times the cosine of 57. If you want to try to type this and then type 4 cosine of 57, those are going to be different numbers. All right, and it shouldn't really require that explanation, but just in case it does, I want to make sure that we're good. So I wanted to show you a little bit about how that simplifying works so that you can get to a point where you are able to type in this awesomeness. The square root of 164 minus 160 times the cosine of 57. So the square root of, and by the way, I said already solved. Obviously, we just have to do a square root on that. So I'm going to do the square root of 164 minus 160 times the cosine of 57. And as long as I type all that correctly, then I will find that the length of that side is 8.7668 or 8.8. X is approximately 8.8, and then whatever the units are. This is what x equals. This is what x is approximately equal to. Here we're going to find the measure of angle x. This one's going to be x degrees. We're going to write our formula down again. C squared equals a squared and b squared, all right, just like Pythagorean theorem, but we're going to minus 2a, b, and then the cosine of this unknown angle. All right, so the unknown angle this time is x degrees, and the side opposite is 4. All right, so I've got 4 squared equals all of this stuff, taking the cosine of x. So these sides are going to be a and b, so I've got 6 squared and 7 squared, I'm just going in order there, minus 2 times 6 times 7 times the cosine of x. All right, so let's do a little bit of our multiplication. Sorry, I wrote a little bit small there. That's 4 squared is 16, 6 squared is 36, 7 squared is 49, 2 times 6 times 7 is going to be 84, 42 times 2, yes, times the cosine of x. And then we can combine some like terms if that's helpful. Well, really here, what we want to do is we're trying to get the cosine part by itself. So let's subtract 36. Let's subtract 49. And let's divide by 84, negative 84. When we take a negative divided by a negative, those negatives offset each other. And so we have the cosine of x is equal to 69 over 84. This should look like an exercise that we did the last time that we were together. And so we will do the cosine inverse operation, the inverse cosine of 69 over 84. And that is exactly what x equals. But we love to approximate x. So we're going to approximate x here, find out how many degrees that is, and we're going to let our calculators do that work. All right? So let's see. and we're going to do the inverse sine of 69 divided by 84. We're going to let, obviously, the calculator there, the inverse sine of 69 over 84, and that gives us 55.2 approximately. 55.2 degrees. All right? And so there we have it. We have found the measure of that angle that is opposite from the side labeled 4. All right? And folks, again, the goal here is to make sure that we can do algebra. Notice how I did not touch my calculator until the very end. Now, along the way, if you need help squaring something, if you need help subtracting something, if you need help, you shouldn't need help dividing something, right? Because it's just going to be a negative divided by negative. It's going to give you a positive quantity here. All right? You don't have to simplify that fraction. Cosine inverse of that stuff, and that tells you what the measure of that angle is. Again, the algebraic focus of using a formula, plugging in the numbers, executing the operations, and then let the calculator do the work is how we should approach this. If you are typing things and rounding along the way, your answer is going to be, you're going to introduce error unnecessarily into your work. So we'll talk about good ways to do that calculator work. And the best way is to save the calculator for the end. See me with questions.